let's do a bit recap. So previously, we have learned about rectilinear motion and continuous. Rectilinear, continuous, three main parameter that we always look at: position, velocity, acceleration, and time. These four things always are the four main parameter that will keep asking you in your assessment. So definition of displacement is a change of position. Velocity equal to time differentiation of your displacement and time. So it's not a division, it's a time differentiation. It's a differentiation equation. Acceleration also, acceleration is a velocity, time differentiation of your velocity. And also you can write your acceleration in terms of position, right? You double differentiation of the displacement. Then when you freeze the time, when you freeze the dt, you rewrite this equation in the dt, you will get a new equation where it's a ds equal to v dv. So these are the equations that we will use to define a continuous motion. Then when we come to erratic motion, we are unable to use the previous definition because it move and stop, the time change. Right? When the time change, the velocity change, acceleration change, position change, and the displacement also change. Okay, so there are 5 graphs: ST, VT, AT, and another 2, VS and 8S graph. And 3 Newton motion equation we derive from the rectilinear equation here, right? We derive them and then we arrive at 3 equations that you can use when the acceleration is constant. So when your acceleration is constant, V equal to VO plus AT, V square equal to VO plus 2AS or 2A delta S, change of position. And the last one is your position. So position equal to VT plus half AT squared. Correct, right? So these are the equation that is important for rectilinear motion. And then we go to curvilinear motion. Curvilinear motion, what is important is the curve. So every curve have a center, right? So every center, when you have a tangent direction to a position, let's say A, your velocity will be tangent to the curve. And also another one is your acceleration will always pointing inside the center. So this is how you draw the vector diagram when it comes to curvilinear motion, right? And recall vector equation. You are told to go home to look at Appendix C, to look at chain rules. Right? So dy dx equal to v dv. Okay, you look at these rules. So, and then you know that vector, for example, v equal to vxi plus vyj plus vzk. And to find the magnitude, you square root the vector vx square, vy square, vz square, and then you square root it. To find the position, you can use trigonometry, right-angled position, right? To find the tangent, sine, cos equation, right? Or because when you become tangent, sine, cos, when you are having a 2D problems, then you can use trigonometry. But when you have a 3-dimensional problem, you need to use vector divided by magnitude. Then you use then you can find the direction, right? This is direction. Okay, so I hope by now you are clear of the equation in chapter 1. Chapter 1 is a very lengthy equation chapter. So far, these are the equations that we keep repeating. And Again, if you are weak in differentiation, you are weak in integration, or it asks you to go home and polish up. So after this class, there's no more excuse that you don't know how to do differentiation, you don't know how to do integration. Okay, so I did give you chance to 3 weeks times to go and polish up. So after this, we'll go very fast in the derivation and application of differentiation and integration. Okay, now another one is just before I forget, there are three kind of graph throughout this module. Linear graph, which is y equal to mx plus c, quadratic, which is y equal to ax plus bx, ax squared plus bx plus c, polynomial y equal to ax cubed plus something. So they are either smiling face or crying face for quadratic. Right, it will be a quite popular question when it comes to quadratics. All right. And what else? Tangent sine cos graph also. Tangent sine cos. Right. So go home and recap on the tangent graph. At what degree y is 0. All right. Okay. Today we'll go into motion of projectile. Means when you throw something, you can predict that the object fall at somewhere. When it's a free flight motion, we can define a projectile at a certain position. For example, at the initial position, right? So let's say you have a starting position at anywhere, and we mark as O, sub O means initial. You have X coordinate, Y coordinate. This is a 2D problem. It can be 3D. We start with 2D first, then we go into 3D. Again, don't panic because 2D, most of the time you use this trigonometry equation, and you can always break your coordinate into X coordinate, Y coordinate, X coordinate. So don't worry when it comes to 2D or 3D. Okay, let's say you have an initial velocity VO, right? Green color vector. It's a vector. So VO. So you know that vector, you can break it. Vector have direction and magnitude. You can break into X direction and Y direction. Okay, X direction and Y direction. Okay. Makes sense, right? Okay. Now, start from here. Motion of projectile. Most of the question when you answer that actually dynamic question, there's an option for you to break all the vector into X and Y direction. Means every time you see a vector, you draw the reference axis X and Y, and then break all the vector into X direction, Y direction. And then you solve for X direction only, you get one answer. You solve for Y direction only, you get one answer. Then you combine, become vector problems. Vxi, Vyj, Vzk, this problem. Then you use vector solution. Let's say this object moving in a curve. Let's say. So if you see this kind of path, you know that this is quadratic equation. Quadratic equation with a negative a in the quadratic equation, right? So when the question mentioned free flight means you ignore air resistance, means no drag, and all the energy was kept along the path. There's no loss of energy, right? So when you have a free flight means all the object on this universe, there is a thing called gravity. So gravity will pull anything that have mass, right? In physics, we define the quantity of the material by using mass, right? Mass and weight is a bit different in engineering dynamics. Mass is the magnitude of how heavy is that things, right? 10 kilo, 20 kilo, that is mass. But under the acceleration of gravity, with its gravity action, then it become weight already. Weight is a force. So don't confuse with mass and weight. Right? So you know that on this earth, we have a constant downward acceleration that pull you down with its negative 9.81. So here, constant downward acceleration, it means that every time you see a free flight or motion of projectile, you can use Newton equation. These three Newton equation for projectile question. Right? Any object that you see in a question that you see that fall from the cliff, it project, shoot somewhere, shoot at a certain angle, land at somewhere, then you can use the 3 Newton motion equation here. Okay, provided it tell you lah, at the constant downward acceleration, or there's a constant acceleration in the motion. Okay, again, by fixing your axis, right? All the axis is to x is positive, going up is positive, y is positive. So when your vector of acceleration is go down, your magnitude or the vector will be negative. If you put positive, when you draw your axis already, and all the value when it become positive, means it follow all the axis direction. So this is the careless mistakes. So remember, in engineering dynamics, always follow the general axis that you draw. Okay. So the vector, when you reach this point, the vector is pointing down, right? So by now you should able to understand or how to draw the resultant vector. This one, already explained just now. It's always tangent to the curve. Always tangent to the curve, tangent to the curve. So you open your finger, so the angle between your index, right, and the thumb will form a 90 degree. So it will give you the direction of the vector, right? So it's a tangent. Same with here, it's pointing down because it's follow this path. So it's pointing down and it's 90 degree to the center of the curve. Okay. So by now you should able to predict or draw the vector for velocity. Same with acceleration. Acceleration always pointing in the center of the curve. But we solve the question one by one. You solve by velocity, then you solve acceleration. Okay. So here you break into Vx and Vy, Vx, Vy. So this kind of case, we mark our diagram with O. O means initial. But most of my habit is I always like to use 1, 2, 3. Like for example, position 1, position 2, and so on. But this is just a illustration. Okay, then mark your position on the things, right? X and Y. Right. So in the beginning, you will draw the white lines, but as you go and more expert in later chapter, you don't need to draw this white line anymore. It means you already understand what happened to the object already. Okay. So there is a R. There's a R means position. This is a curvilinear motion. You know, projectile is a curved motion. So you always have a R to represent. Okay. So curvilinear motion, you are using R and not S. You're using R. So what happens if you drop a hammer in a vacuum? Which one will fall first? Which one will touch the ground first? It was same, So this is there's a video on that. So you will reach the same. So just in case you haven't watched this video, it was on the moon, right? So this moon, this astronaut, this is hammer, this is a feather on the astronaut hand. Then he dropped the two objects same time. Of course, on the moon, the gravity acceleration is not 9.81. It is some weaker than the Earth. So the object reached the same time when you drop in the vacuum. Okay, now recall these three equations. Right? It's important and it's your best friend. So when they come to your assessment, test 1, test 2, final exam, general equation, there's some marks there. So always write general equation before you solve or substitute answer. Right? So you can break into horizontal motion and vertical motion. Okay. So for projectile question, remember always break into X direction, Y direction. And then you're able to solve any projectile question already. So what I mean by X direction, Y direction? Means all the direction in X to the left is positive. And you know that our acceleration is always pointing down. The vector is pointing down, so there's no AX direction. So when no X direction, what happened to this equation, right? So the first equation will become, the first equation, V equal to V naught plus AC, because AC you break into two direction. One is X direction, means Vx, Vox, ACX. So X is 0 because your gravity is pointing down. So you cancel the second one. Then Vx equal to Vox or XO, means the X direction will be same as the initial velocity X direction. What happened to the second one? If you apply the same, all the equation will arrive. This one will become 0, right? So this one also cancel. You arrive at XO, this one XO, and VO, VOX. Remember that you are now looking at X direction. So here I just change the X into X, S into X. But in your solution for your assessment, you don't need to change into X. This is just to tell you that on the coordinate, X direction is that. So X is, you look at the X direction. In your assessment answer, what you need to do is you just mark this one as X, or you just solve this one in X column. Then I know your answer, this one is for X. Okay. Or you write your answer in the solution, in your question paper, in your answer sheet. You straight away you draw half your line. You draw a half line. You write X direction, Y direction. So all the equation you write this side, all the equation you write this side. Okay. So like for example, the one you see on the screen here, all this equation you write on the left-hand side of your answer sheet with the X direction. Right. So same apply for the third equation here. So this one 0, this one square, it will prove the first equation. Because this is 0, you square the two things, it will same as the first one. Okay, same. So this one will be the same. Although the notation is different, but I just want to differentiate. This is using the third equation. They actually mean the same thing. Okay. Yeah. Where? Displacement. This one? Uh-huh.
Why there is a S? No.
This one is a delta S. This one, if you take this one to here, S minus S0, it's become a delta S, right? It's a change of displacement. So I mean the one that I write on the whiteboard is I do it a quick way. Right? Of course, you want to write this way also can. It's a bit lengthy way. Right. So if you understand the horizontal, you should able to do the vertical, right? Vertical, what happened to your A? What happened to your A, the yellow color component? What is A acceleration in Y direction? Positive, negative? Negative, negative. So the equation will become, and based on your general equation, general equation, all the Y is positive going up. So in this case, on the earth, when you throw something, acceleration will pull you down. So acceleration will be negative G. So of course, in the question or in your solution, you can straight away write AY equal to minus 9.81 if you want, right? So this is just an illustration. So the first equation, you substitute AC become minus AG, minus G. But this one is in Y direction. So on the right-hand side of your answer sheet, you write Y direction answer. Same three equation, you derive into six new equation for vector for projectile question. So 3 on the left, 3 on the right. The only difference here is acceleration component, right? So you apply the same. Second equation become negative G, right? Of course, the V velocity here is Y component. This is Vy. This one also Vy. Okay, Vy. Okay. And the displacement here is Y direction. It's not X direction. Displacement here is Y direction. So try to like differentiate a little bit. What is the difference? Apply the same for the third one. Same. Again, V here is in Y component. AC here is G, but it's negative G, right? And the displacement here is Y direction. Okay. So I always like to write my answer. If it's Y, then it become Y. If it's X, become X. Or put something below there to represent, to remind ourselves this is Y direction or X direction. Okay, so you have 6 equations. Then you can solve the missing part. You can solve the missing part from the question. Okay, these are the general steps when you solve chapter 1 question. Okay. Sometimes the A will become positive. It depends on the way you throw it and the time you look at it, right? So again, this scenario is that you throw at the Y positive direction. You throw at this like going up direction, so Y positive. So if the object was thrown from this direction, then you need to be careful. But again, you just follow the motion, right? All right. So let's look at an example. So when you have a set, this one is from the clip. That's a kind of clip of problems. It doesn't ask you what happened in the beginning. It asks you from the point where you start to free fall. Okay. So the one that asks you from initial to here, that one is the previous section. If the question asks you what is the velocity at this point, then is the previous solution here. Okay. If it asks you from here to here, then it asks you the velocity here, acceleration here, then use the previous curvature motion. Use for curvature motion to solve. But here, this question it asks you is slide off from 12 meter per second. If the height ramp is 6 meter here. So if from the ground, so this sack start to slide down. The height from here to here is 6 meters. Determine the time needed for the sack to strike the floor and the range R where the sack began to pile up. Means if you think logically, right, since you are taking degree level, you should be able to predict something based on equation. So here, you know that when this one reach here, it will not drop like that, right? So it will zoom then like that, right? The motion will be like that, right? The motion will be like that. So you can draw the path, predicted path, which is like that. It will not be like straight line, it will not. But because of gravity, you will form a curve motion. Okay, so it fall like that. So most of the time, question you only see this one. The rest you need to show that you understand the question. So for example, you draw the path line and you start to solve for it. Okay. Now in this case, my A equal to G and my G positive go down. So don't try to confuse with the previous slide that I showed you. Right. Now my positive value, my positive direction go down positive. So my acceleration is positive. Make sense, huh? So don't confuse. It's why last slides you show negative. This is positive. Okay, there's a different and my suggestion is that always follow the motion and the starting point motion. Follow the starting point motion. So let's see. Sometimes my answer will follow the axis, sometimes I'll just follow the motion. Right. Okay, so you're given the horizontal velocity, you have the initial velocity in x direction. This is a vector, 12 meters per second. Right? And this is in the x direction. So when you see this kind of question, you know that this is projectile question. Projectile question, straight away go to your answer sheet, draw half if you want, right? I would recommend you draw half. Left hand side, you write x direction. Right hand side, you write y direction. Then maybe in the beginning, you can write the 3 Newton equation because this is a projectile. So you need to use the 3 equation, which is right on the whiteboard here. Right? You write these 3 straight away, you get 3 marks. Without solving projectile question. You write these 3 correctly, you write 3 marks. I not even look at your substitution yet. You write these 3 straight away, you get 3 marks. But must be correct one. You write this general equation, you get 3 marks. So how to solve? First, when you use these 3 equations, remind yourself, engineering dynamics, you need 4 parameters: position, velocity, acceleration, and time. Right. So first thing you look at is, do I have time? Can I find out time? Right. So actually you can find. All right. So I remove the question. I start solving the question. So on the left hand side of my answer sheet is go for horizontal. So horizontal and vertical. Of course, because of the size of the PowerPoint that I have, I write in the this way. So on your answer, I highly recommend you break into half. Left hand side for x, right hand side is for y. So for horizontal, you know that your ax is 0. So again, you refer back to the 3 Newton equation. You derive the equation, means ax equals 0. So this one you will see the equation on the screen here. Second equation, you arrive at this x something, and then the third equation also same as the first one. Right? You don't need to memorize this one. You only need to memorize the 3 Newton equation, and then ask yourself, what is my acceleration in the x direction? It is, if it's free fall, x direction always 0. Right? Ax is 0. Right? So you arrive at the 3 equation there. You don't need to memorize this red color equation. Right? So the first one, AX equal to initial X. Means velocity here in X direction will be the same as the initial. So what is your initial? Your initial is at A is 12 meter per second. So this is your AX component. So you substitute AX there. So you write the first one, you already solve. The first one, left-hand side answer, already solved. Vx, you write Vx means the second point here. Vx will same as AX or VBX. VBX will same as VAX. Is equal to 12 meter per second. You get 1 point here. You just write this one, you get 1 point. Means you understand the substitution of AX equals 0 in the Newton equation. Okay, then you look at the second equation. Right, second equation. So second equation is this one. This is the X direction, right? This is the X direction. So this is the final location, but early equation. You look at X direction only. So the differences of B and C on the screen here is your R, right? Of course, you no need to label R if you don't want to, is okay. You can write this one as SB, SA also can, right? Because this is the position in X direction, right? ABX, SBX minus SAX also can, right? But just want to simplify, I label this one as R. So your R equal to R means the second location here. Maybe some notation wrong here. I should write VBX here or XB here. I should not write R, but R is the difference between A and C here. Okay, right. So when you substitute the value, you know what is your AX, right? This is VOX. You already solved in the first part. So you just substitute here, 12, and it's positive going to the left. Going to the right. Then you know what is the position of AX? XA. What is your XA? 0. This is your reference point. 0. Okay, this is a hidden information. 0. Then this is the final position. Okay. Okay. Next, we go into Y direction. Same. You recall the three equation. Remind yourself, okay, now my acceleration is going down. So in this case, you see the equation is negative. So our positive direction in the question is going up. And this is just to remind myself that the gravity going down. So my equation, you see negative, means my reference axis is all, if it go up, means positive. So that's why you see negative inside. You substitute. Okay, you substitute. I choose the second one. You can proceed with the first one if you want. But here, because I know my position, Y direction. First equation, I don't have any information for Y. So I skip to the second one. Second one, I have position. This minus this one, I get this one, these two, right? So you move this one to the left, you get the displacement of 6, right? All right. Now, so here, again, this is positive. This is 0, a reference point. Go up positive, go down negative. Displacement from one point is a vector. Vector go up positive, go down negative. That's why I highlight it in the blue color, -6 meter, because it's go down from the reference point. Make sense? Okay. Then YA. YA is the position of the reference point. Here, 0. Right? VA. What is your VA? VAY. It tell you already, initial move straight x direction, 0. So your y is 0. Of course, you won't see this kind of question in the assessment. It will give you an angle of throwing. Right? So you need to break this one into x and y. Okay, in this case, your VA is 0, VAY is 0. G, you know 9.81, you can substitute. So there's only one unknown inside the equation. It's a square, it's a quadratic equation. Again, when you solve the quadratic equation, you need to judge which one to use, either positive or negative. Because you square root, you have a plus minus answer. You have a positive root and negative root. And you're dealing with vector. Vector means positive means it follow along your axis. In this case, if you want a positive, of course, time don't have negative. Time always have positive, unless you are studying quantum physics. You're studying about time, history. You need to go back to history or project to the future. Then, yes, for dynamics, we always use a positive for time. Okay, so you get 11.1, 1.11, for example, right? Then you go to the second question, right? You go to the second question. Okay, first question, this one, horizontal motion. Just now, horizontal motion, you stop at 1t, right? You're not able to find the time here. That's why. So here, when you reach this one, it's okay because your answer sheet is on the left-hand side. The left-hand side x-axis here. You stop at this equation, right? XA bracket 12t. You don't have t here. But on the left-hand side, on the right-hand side here, now you arrive at one answer, time equal to 1 point something second. So when you have this answer, what you go back, you check with the left-hand side. Left-hand side, you need t, so you just substitute your t inside here, you get your r. So it's like you run parallel equation, parallel analysis. You look at x, you look at y. So which one comes first? You get answer, you substitute here and there. Sometimes you substitute to the left, sometimes you substitute to the right. So that's why I recommend you break your answer into left and right. It's more convenient for you to check. If you answer something like what I did on the screen here, it might not. Of course, if you do a lot of exercise, you know what you're doing. But it's better you do left and right. Okay. Now you get the R is 13.3. You know the R already. Means you know the S. Okay. So the answer is 13.3. Okay. So I give you another example. You will see that the procedure always repeating. I mean the concept of solving always repeating. Yeah. So maybe this one might be still very new to you, but I will show you a second example. Try to observe the patterns of solving. The procedure always same. First step do what, second step do what, still the same. The differences is the question how it asks you and what is the value given. Okay. Now the second one. Second one is about chipping machine. So some of you don't know what is chipping machine. Chipping machine is that things that you process wood, you throw in something there, it grind. So this one will throw the chip, the wood chip out. Okay. In Malaysia, it's rarely you see this one, but in Europe or other country, this is quite normal because they need to clean up their gardens and they have a very big gardens overseas, right? So chipping machine designed to eject wood chip at a velocity of 75 meters per second. So it give you a value. Okay, they give you some value. Okay, all okay. So it give you a velocity at 7.5 meters per second at a certain angle. If the tube is oriented 30 degrees from the horizon, means this mouth here that shoot the wood chip, it will rotate 30 degrees up. So the wood chip will shoot at 30 degree at 75. So you have an angle here. Right. Determine how high is H the chip can strike the pile if at this instant they land 6 meters from the tube. Means you put in the wood here, you will throw wood chip, then the question asks you, at the distance of 6 meters, what is the maximum height that it can power? So how you solve? Actually the same. First, establish where is your origin. This is your origin. Mark the origin point first. Then from the origin, mark your compass or your axis. Where is positive, where is negative. So y going up positive, x going to the right positive. So establish your x and y axis. Mark the origin, establish xy. Okay, when you establish xy, you know already the point that you need to calculate. So here to here is 6 meters. You don't know the h. There's one point here. So here is a random number. You don't know where it is. You want to calculate. And the height from the ground to the mouth there is 1.2. Okay. So this is the initial y or initial x in y direction. Okay. So there are few information you already have. Okay, so to solve, I know you look at the question, you know this is the projectile question, chapter 1 question. Question 1, question projectile, straight away write the 3 equations in your answer. Write these 3. Write these 3, right, V, V2, V square, delta S. Write these 3. Break your answer sheet into half. Left is x-axis, y is y-axis. Okay, then you fill in all the information you have from the question. Okay. Now, so the wood chip will land at somewhere. At 6 meters, you don't know the height, right? You don't know the height of that one. Okay. So the first question is that you have an initial velocity of 7.5 meters. When you break into x and y direction, recall trigonometry equation. This is the 2-dimensional problems. It don't give you the z direction, right? So recall what is tangent sine cos. You can draw a small rectangular and then write the opposite side hypotenuse, that equation by the side. Right? This one, sometime I can give you marks also if you mess up with your substitution. This will be your life jacket. If something wrong with the substitution, you press the wrong button, calculator, all the rest is wrong answer. I will try to find you know how to do trigonometry. Then I will give you some marks there. Okay, so this is just a backup. But if you get the right answer, this one just a part of your answer lah. Okay. Right. Now, if I mention the starting position in the x direction is VO cos 30, you should able to understand, right? Do I need to write this one, derive this one for you? No need, Do you need my help to show you the green color answer? Do you need? No need, Okay. So the first one, you break this one, 30 degree into x direction. So this is a triangular. Use your tangent cos theta. You move. You are interested in this component, right? So you get the one in green color. You press calculator, substitute initial velocity 7.5, cos 30. You will get 6.5 meter per second. Okay. Your first job is to break all the components you see in the question into x and y. Okay, there's a certain procedure. Every time you follow this procedure, you should be able to solve the question, right? So y direction also, when you break into y direction, this vector break into y, Again, trigonometry is rectangular. You are more interested in this direction, right? So it's a sine, VO sine 30. Who don't know how to get 330? Let me know. One okay? Okay. Press calculator again, sine 30, multiply by 7.5, you get some answer. Right. Okay. I draw the blue arrow because I don't have the left and right column. Right. So if you have left and right, then straight away, X1 you do on the left, Y1 you do on the right. Okay. So we have the initial X and Y. Then you do for AX. Right. So AX here, this is A, point A. Right. Sorry, this one. The second landing here, AX. So you'll get the same as 6.5. Of course, to arrive at the third row, you pull out the three equations, substitute, ask yourself, where is your acceleration direction in X in projectile? 0. Huh? You write AX equals 0, substitute in these three equations here, you will get the third line of a green color there. Okay, you'll get AX with the second point here, AX equal to initial velocity in x direction, which is 6 meters per second. Okay, so this third equation here is on the left hand side of your answer. Okay. So there's a step I already skip a lot for AX. I don't go to the substitution anymore. Right. So what you do, you write this answer in the free body diagram. Once you have the answer, you write your answer there, VOX 6.5 something. You write so that you remember. You already solved for this component. Okay, AY is negative, right? AY is negative. Okay, so this is what I do. So again, I don't go back to this red color anymore. I assume you know how to substitute the value, right? AX equals 0, you arrive at these three equations. Okay. So you already solved the first one just now. Now we do the second one. Second one, you look at the X direction. X direction, do you know? 6 meter. 6 meter is what? X minus X0 means you move this one to this one. Or what is X? X is 6. What is XO? 0. This is 0 point. This is 0 point. So this is 0. This is 6. Okay. So what is your VOX? VOX you already calculate just now. You already have the answer. You don't have the time. So you are now stopped at X direction. You need time. So don't panic. Go to the Y first. If you stop there, go to the Y. Continue with the Y. Then compare. Do I have any answer? If have, then substitute back. Continue, calculate. That is a trick. Okay. You substitute, you get, in this case, you already have the answer. So you have the time. On the left-hand side of your answer, you can get the time already, which is 0.9 something. For this module, minimum 2 decimal place, maximum 3 decimal place. Remember the unit. Don't forget about unit. Time is second, velocity meter per second, acceleration is meter over second square. If you miss out the unit, again, straight away 50% discount for the answer. Okay. So for the vertical side, I call out the equation that we derived. Same, you pull out the three equation, and then you write A equal to negative G or negative 9.81, or you arrive at these three equation. You substitute, then you get this three equation, right? Okay. So since you already have time, I use the second one. So second one, I already have the position, the Y position I have. Already have. So my YA here I take h minus the 1.2. I assume that the h is higher than my initial position. In this case, I assume it's higher. Of course, if you assume lower, you take 1.2 minus h. There are two assumptions. One, in this case, the one that you see on the screen here, I assume the wood chip power up higher than the initial. That's why you see h minus 1.2. Then yo 0, because here is 0. You see as a Cartesian position problems. This is 0. So 0. Vo y you already find just now from here. Define. Okay. From the trigonometry equation. Substitute value there. Time you already have. Right? Time you already have just now from the left-hand side of your answer sheet. Right? Then half G is minus 9.81. Okay, in this case, I substitute negative. It should be positive. But if you use negative, this one is not wrong. But I assume that when it reached there, I'm looking at going down. Right. You can use positive here. This one you can write positive. Okay. So you get h equal to 0.48. Okay. So on my answer, my PowerPoint slide here, this one should be positive. This one should be positive, then negative. But if you write like what you see on the screen here, negative, negative, is also correct. It's just that you assume you're following the motion. Okay. So the one that you saw here is it should be positive positive. Then you are following this equation. Okay, you're following this equation. Okay, so can you solve with the first one? Also can. Also can. Right. So with this we conclude. Not conclude For the first part of chapter 1, we go for a short break. We continue. Maybe 5 minutes breaks. Then we continue. 9:05 we continue. Sign your attendance.